Hi, I'm Bob Tabor with LearnVisualStudio.net. In this lesson, I'm going to show you another decision statement, the select case decision statement, and then we'll talk about enumerations as a way of limiting the possible values within a given property for your class and how the .NET Framework uses this extensively. So first of all, let's recall from our discussion with the if decision statement back in, I believe it was lesson number 6. Actually, I have the project, the decisions project, loaded up here. And you can see in this example we used a number of if, else, if statements. If user value equals 1, then execute this block of code. Else if user value equals 2, then execute this block of code. Else if user value equals 3, then execute this block of code. And so on. And honestly, this approach worked just fine. But generally, if you have a lot of potential values that you need to match or find a match against, then you can write this same intent just a tiny bit more succinctly using the select case decision statement. I wanted to demonstrate that. So let's do this. Let's create a new project, and we'll call that Understanding Select Case. And then I'm just going to begin typing away here. Okay. All right, so simply put, we're just going to ask the user for some input, and then we're going to compare whatever the user typed in using this select case construct against a series of options. So the succinctness comes in that we don't have to type in the then, else if, and so on. It's just a straight comparison. What's equal to that? Is it this? Is it this? Is it this? No, then execute the case else, the catch-all statement. All right? So let's run the application, just run it real quick. And first time we run it, everything works just fine. One of the reasons why is because I was careful about what I typed. Second time through, however, let me just type in all lowercase. I'm going to show you one of the issues with accepting input from users. I'm not using the proper case, the capital B. I'm using a lowercase b. And so it will not find the right case. So just be aware that whenever you're accepting input from a user, you may have to use a to upper or to lower. This is a common technique that's used to do a comparison. So once we change around all of these, then we can run it again, type in whatever we want. As long as it's spelled correctly and there's no additional spaces or anything, we'll be just fine. Okay, so in a nutshell, that's what a case select statement is. What's the basic difference between the if statement and the case select statement? Well, frankly, in some situations, it can improve the clarity of your code, especially when there are many possible values that require an evaluation and you're just doing a simple what equals this? Is it this? Is it this? Is it this? And so on. All right. So there are occasions when you would probably prefer to use an if statement because it's much more flexible. You can do a lot more with it. And I'll give you an example of that here. Let me open up an example I already created called complex if statement. It'll be available for download if you want to inspect this. I'm just not going to type it all in right now. And here I'm going to show you how you could use an if statement to enable a more complex evaluation. Here we're asking for a number between 1 and 100. If the user types in a value smaller than 1 or greater than 100, then we can say, well, that didn't work. It was out of the boundaries of what we asked for. So notice that we're concatenating two comparisons together using the OR keyword. We're doing the same thing here where we're saying if the compare value is 42 or 23, or if it's greater than 90, then you found one of our special numbers. Otherwise, as long as it kind of didn't satisfy either of these conditions, then we'll just say, well, you didn't find one of the special numbers. Let's run it real quick. So when I type in the number 23, I found a special number. If I type in the number 24, you didn't find one of the special numbers. And if I type in 123, I'm way out of bounds. All right. So you can express some very complex decisions using the if statement. It just requires a little more verbosity, I guess you'd say. And so it's just a small trade-off. I wanted you to be aware of the select case because you'll see it often in code examples and just understand what it's there for. Okay? All right, let's move on to enumerations and we'll tie these two concepts together. Enumerations are a data type that only allows a small list of possible values. So enumerations constrain the data, forcing it to comply by being only one of several possibilities, and in so doing, it makes your code much more reliable. Generally, comparing magic strings against each other is bad programming practice. We've already seen the dangers just a moment ago in comparing strings. If you compare something that's uppercase versus lowercase, you may not always get the results that you want. Well, the .NET framework uses enumerations all over the place, so it's important that you know what they are, and we're even going to demonstrate how you can create a simple enumeration. But basically, the creators of the library set property values equal to or of data type some enumeration that they've created to force you to select one of several possible values, as opposed to just typing anything that comes off the top of your head and then hoping that it works and then experiencing some error at runtime. So let's go ahead and create a new project. We're going to call this Understanding Enumerations. And let me just show you one simple way that it's used in the .NET framework. So we've used the console class quite a bit up to this point. If I were to try to change the foreground color and I see that it's of type console color, what does that mean? That's not string, that's not an integer, it's a whole different type. Well, you get a clue once you hit the equal sign. IntelliSense shows you a list of all the possible values. So it's an enumeration called console color with several default colors defined: black, blue, cyan, dark blue, and so on. Let's suppose I want to choose, let's go for red, and then we'll just do this. And let's run the application, and you can see that it simply now prints out in red. So again, an enumeration constrains the possible values. We can't just type anything we want in there. The .NET framework only understands certain values. Now, fortunately, IntelliSense will push you, will nudge you in the right direction by opening up a list of possible values. So that's the neat thing about enumerations. Let's now take a moment and create our own enumeration. So to do that, I'm just going to right-click on my project, select Add Class. I could choose any of these, really. I just need a .pb file. Let's call this Superheroes. And I'm going to change this from public class superheroes to public enum superhero. And get rid of this end class part. And then I'm going to type in the names of the superheroes that I want to enable. So now, in my application, I have a data type called superhero. If you ever want to make a property or a variable of type superhero, it can only be one of those three values. Or I could add more, but only for now, one of those three values. So let's save our project so far. Let's create a little application that flexes this notion. I'm going to move some things around here. And I'm going to change this to what we did earlier. Type in a superhero's name to see his nickname. Now before I do that, let's just do this. Dim my value as superhero. And if I try to set my value in code, notice, whoops, my value in code, notice that it gives me superhero.batman, .green lantern, or .superman as the only possibilities. Okay? And it satisfies it. But here I want to allow a end user to type in a value and then try to get it converted to my enumeration. This is a little trickier, a little outside of the scope of what we're really trying to prove here. But let me just demonstrate it just for so that you can see it at work. All right, so let's grab the user's value. So dim user value as string equals console.readline. And now let's just try the first pass just to see if .NET can figure it out without us intervening. Okay, we're going to try an implicit data type conversion and watch the sparks fly. And then we'll come back and maybe tackle this again a little more reliably. Now this time, instead of just using magic strings to compare the value, I can do something a little more strongly typed, relying on the enumeration that I created earlier. Green Lantern to get mad, so I'll spell it right. And for now, I'll just do case else nothing. This should never happen. Okay. All right, like I said, let's watch the sparks fly here as we try to run this application. So let's just type in Batman. And this isn't going to work. An invalid cast exception, trying to convert from string Batman to type integer. What? Integer? Yeah. So what happens here is whenever you're creating an enumeration, you're basically giving each of these values a number implicitly. Now we can reset these numbers, but behind the scenes these are implemented like this. So we could say instead of the default numbering, I could change things to like this numbering scheme, for example. But enumerations are behind the scenes storing off integers. So this basically is not going to work. We're going to have to find a different way because the implicit conversion just ain't going to happen. So what we can try to do here is a little more advanced, but I'm going to show you how it's done in case you ever run into a scenario where you need to convert a string into some enumeration. So I'm going to wrap this select case with a try parse. So if enum dot, and notice that it automatically put the square brackets around for me. All right, I didn't type that in. So try parse. Now what data type are we going to try to parse our string into? Well, of superhero. Again, this is a very advanced notion. I don't want to talk about generics right now. So just follow along and remember that if you ever see of tenum, it's asking for a data type, and the data type we want to turn this into. So of superhero, and now I'm going to open the parentheses and pass in two values. The value, first of all, that the user typed in, the string, and then what we're trying to convert it to, a type of, where we're getting the value rather, my value. Then, all right, so here's the thing. Let's type that in there. Great. We're going to try and convert user value into a superhero. If we can successfully convert user value, which is of type string, into a superhero, then we're going to store the value in my value and then continue to execute any block of code inside of the if statement. If we cannot, then we will not execute that. We can just do something like this instead and just give an error message. Console.writeLine unable to find a superhero by that name. Okay, that's what try parse. It's going to attempt to parse our string, turn it into this data type. If it can, it will store it in my value. So let's run the application now. And let's try Batman. Whoops, we got to get rid of an old line of code. Let's just comment it out and stick the new line right below it. All right, here we go. This will work, I think. Hey, it worked. Now, let's run it a second time and see where the challenges are. So here again, we run into the issue that we ran into before. Converting from a magic string that the user types in into anything else, much less an enumeration, has its challenges. You might want some blended approach where you are doing the type of conversion that we saw before to clean up the data before you attempt to turn it into enumeration. But I don't think this is something that you'll need to do very often. The key notion of this lesson, well, let's recap them. First of all, we talked about the select case statement. We've seen a couple of examples of it and where it's strong and where the if decision statement actually is a better option. We looked at enumerations, especially those that we see in the .NET Framework class library. They're used all over the place to limit the possible values that we can use for a given property of a class. We then created our own enumeration to limit the possible values for use within our own application. And then we saw how to use the enum.tryparse method. And we intentionally skipped over that of superhero part. I said something about generics. Don't worry about that. You'll get to that much later on. Just know that you'll need to put the data type in there, what you should expect to be parsed, but you really shouldn't have to do this very often. I just wanted to demonstrate it in case you ever did run up against that. Okay, so let's keep pushing forward. Every little bit that we can learn about the .NET Framework helps us build this mental model. And so you're doing great. Hang in there. We're almost done. See you in the next video. Thank you.